All right, so this week is on meiosis. Meiosis is a little bit different than mitosis. So we're on the book, page E121 is on meiosis. If you go back to page E83, here's mitosis. Remember in mitosis, all 40, like if it was human beings, all 46 chromosomes would be lined up on the equator, and their sister chromatids, the copies, would be pulled apart at the centromere. That way all 46 end up on both sides and you end up with a cell that has all 46 chromosomes, okay? The chromosomes come in pairs. We have 23 pairs. And those pairs, you get one of the pair. So like chromosome 1, you get one of those from mom and one of those from dad. But they count to the total of 46. But they come in 23 pairs. Those pairs are homologs. They're homologous chromosomes, and they talk about the same thing. That's why the prefix homo is there. So in this one, the big difference in meiosis is that in the first part, meiosis 2 is a lot like mitosis where they line up in the middle. But in the first part right here, in meiosis, those pairs of chromosomes line up next to each other. So like, let's say that this is chromosome 1, here's the mom and the dad pair, and here's chromosome 2, the mom and the dad pair, and those pairs will be separated. So now you only have over here 23 chromosomes, okay? And then that will come down to here where now those separated pairs, so here's chromosome 1 and 2, here's chromosome 1 and 2. Okay. All right, and so those split pairs now, we can put that into a Punnett square and predict what are the probabilities that offspring will get the traits that are on each one of those genes, or each one of those chromosomes. So we'll look at eye color again, and we'll do one that's near and dear to me. So we'll put dad up on top here, and I know that dad has brown eyes, but I know that he carries the trait for blue eyes. So brown eyes dominant, it's the big B. Blue eyes is recessive, it's the little b. And we put them in that order too. It would always be big B, little b, the order that we're putting them in. Okay. And mom is a little b and little b, okay? She has blue eyes. To get the recessive trait to show up, you have to be homozygous, so talks about the same thing at the same spot. So eye color is talking about the same thing, both little blue. Whereas dad up here is heterozygous. He has different alleles. They're talking about different things. So both on eye color, but this one says make the gene, or has the gene to make the brown color. It's a pigment called melanin, and the blue doesn't do that. And so that's what kind of makes them dominant. Dominant genes tend to make the protein. And so it gets made and then it shows up over the blue. So we could predict now what would be the probability of having offspring and their eye color. So the big B, we're going to do that one first because it goes front. Big B comes down, big B comes down. Okay. Little b, it comes down and it meets. Well, we'll finish this one first. So little b comes over, and this little b comes over, and little b and big little b, two little b and a little b, those all come over. And here you go. This is the probability for their offspring. So when you look at this, they have a 50% chance of having kids with blue eyes. They have a 50% chance of having kids with brown eyes. They have a 50% chance that those kids with blue eyes are going to be homozygous for blue eyes, and a 50% chance that it'll be heterozygous for brown eyes. Okay? All right, and so on a Punnett square, here's what that looks like. So I know that guy who is heterozygous for brown eyes, and we'll color in one side. So he is got brown eyes, but he's carrying the blue trait. And I know that mom is blue eyes, so both are blue. And they had, let's just make it up, they had 3 kids together. They had a daughter, and then a daughter, and then a son. And I know that the daughter, born first, is brown eyes, but I know that she's carrying a trait of blue that she would have gotten from her mom. She got the brown from dad. And I know that the second daughter is brown eyes. Again, got that brown-eyed trait from dad. Keeps that blue-eyed trait from mom. So these are both heterozygous for eye color. And the son got the dad's blue-eyed trait that's not showing up there. And that mixed with the mom's blue-eyed trait. And we can go back farther in time. So I don't know who this guy is, but maybe he texted his mom earlier this morning. He knows that his mom is blue eyes and his dad is brown eyes. But what you don't see here is that they have a brother. This guy has a brother. Maybe he won an Olympic gold medal at one point, but he's got blue eyes. So I know that the dad has to carry the blue-eyed trait too. So I can go back even further in time. Talking to, I don't know who this is, but he was talking to his mom. And he had a picture of Grandpa, but he always wore these glasses that changed colors. They shaded in the sun, and all his pictures are from him outside. Grandpa was blue-eyed, Grandma was brown-eyed. I'm sorry, blue-eyed as well. We can change this up and go look at the dad's side. Oops. So on his dad's side, has brown eyes, and Grandma, or for the kids, in the kids' instance, great-grandma would be brown-eyed and carry that brown-eyed trait. He knows this because none of the kids, and he has, so this is great-grandparents, grandparents, brothers and sisters all have brown eyes. So always getting a brown-eyed trait, at least one brown-eyed trait. So probability, because that blue-eyed trait is in there, that it's hiding on, the blue-eyed trait is hiding in one of the great-grandparents. But this was a real quick pedigree from the offspring. Great-grandparents, all brown eyes. Grandparent has brown eyes but carries the blue. Grandma has blue eyes. The father has brown eyes but carries the blue. The mom has blue eyes. And then the offspring, brown-eyed, and blue-eyed, even though there was, like we just saw in the Punnett score, a 50% chance.